So to begin, it is my pleasure to welcome California State Senator Carol Liu of the 21st District, which includes Pasadena, who will introduce our keynote speaker, Mary Nichols.
Good morning. I joined Caltech and JPL in welcoming all of you to this important symposium. The view from space provides both the global context of changes on Earth and the local and regional impacts of those changes. I hope you'll all have a great day as you share and discuss ways for delivering actionable science to policymakers. We need the information. And it's going to be my pleasure, it is my pleasure to introduce to you your keynote speaker, my good friend, Mary Nichols. Mary Nichols is a nationally and internationally renowned expert on and advocate for air quality and public health with a firm grasp of both the science and the law. She was appointed chair of the California Air Resources Board in July 2007 by Governor Arnold Schwarzenegger, returning to the Air Board 30 years after serving as chair during Governor Brown's administration. As one of California's first environmental lawyers, she initiated precedent-setting cases under the Federal Clean Air Act and California air quality laws, while as a staff attorney for the Center of Law of the Public Interest. Mary has also served as assistant administrator for the U.S. Environmental Protection Agency's air and radiation programs in the Clinton administration, secretary of the California Resource Agency in the Davis administration, and director of UCLA Institute of the Environment. She holds a Juris Doctorate degree from Yale Law School and a Bachelor of Arts degree from Cornell University. In her return as chair, Nichols' priorities include advancing the state's landmark climate change program, curbing diesel pollution at our ports, and developing regulations aimed at providing cleaner air for Southern California and the San Joaquin Valley. She values innovation, partnership, and common sense approaches to addressing the state's air issues. Please help me welcome Mary Nichols. Mary.
Well, thank you very much, Senator, for that very kind introduction. Thanks to Caltech for inviting me, or for the sponsors of this very interesting meeting. And thank you. As you've just heard, I have a very long career as a bureaucrat in various governmental agencies. And as a bureaucrat, I really prize acronyms. It's not every day you get to learn a new acronym. And so to have the word KISS, which until now meant either something very lovely or a motto, keep it simple, stupid, to now have another meaning for the word KISS is really, that's an addition to my arsenal, but I don't think it's going to be the only thing I take away from today's meeting. First of all, let me begin by acknowledging that we in government have a long way to go in making effective use of the kinds of information that many of you in this room help to develop. And there are many reasons for this, many obstacles along the way. But one of the surest ways to get people fired up and to allow us all to see ways in which we can better interact as well as to develop new tools is to have the kinds of discussions that you all are having here today. And I really want to emphasize, particularly in a time when many of the issues that we're dealing with in government, including environmental regulations and increasingly the implementation of programs to deal with global climate change, are compartmentalized and contentious and tend to be characterized by rather sterile debates sometimes about what can be done. So opening up our eyes to new opportunities is sometimes a way out of that box. But I do want to share a few thoughts about where we are right now in the process and perhaps some ideas about what some of the things that we can that we could look forward to working on together, taking advantage of advances in technology and better access to data. So before I do that, I think I need to at least start with a little bit of basic information about who we are, who the Air Resources Board is, and what our role is, because we're only a piece of the puzzle even for the state of California. But we do have some rather unique roles and responsibilities. First and foremost, of course, we're responsible for implementing all state and federal laws with respect to air pollution control. We work with local air pollution control agencies to help them meet their obligations to control local air pollution sources. But we also have a primary jurisdiction over motor vehicles and consumer products, things that classically move in interstate commerce and that are nearly impossible to control effectively if you're looking at just pure regulation at the local level, although of course there are other tools that are available to us, but when you talk about just legal tools, the state is the one that gets to deal with mobile sources. We also set ambient air quality standards. That is, we define what clean air is on a pollutant by pollutant basis. And in some cases, because California has maintained a strong program since before there was a federal program, our standards are more stringent than the national standards are. And of course, that's true for motor vehicles as well. We also maintain an ongoing research program, an external research program that funds work on health effects, air chemistry, pollution control technology. And of course, last but hardly least nowadays, we were designated as the lead agency under AB 32, the California Global Warming Solutions Act of 2006, as the agency responsible for planning and implementing the state's goal of reducing our contribution to greenhouse gas emissions, including the carbon emissions from the electricity that we use in the state, regardless of where it's generated, back to 1990 levels by the year 2020, a goal of about a 30% reduction in emissions. So we have a full plate, and we have about 1,100 people all told in Sacramento and in our El Monte lab and a few other places that are tasked with carrying out these responsibilities. So how do we do it? Well, first of all, we believe that our program is science-based. And from the earliest days when the Air Resources Board was founded back in the late 1960s, it's had a very strong commitment, regardless of which political leadership was in power, towards being technically the strongest air quality agency anywhere in the world. And this is a matter of great pride to our staff. It goes back to the days of our original chairman, Professor Ari Hagenschmidt, who probably not many people here ever had a chance to meet. I did. He was is known as the inventor of smog. He was the person who, in his laboratory at Caltech, actually mixed up the chemical formula that was smog and showed people why it was that they needed to control combustion in their backyard incinerators if they wanted to get serious about doing anything about air pollution, and that they were going to have to move from that into looking at the automobile. So Dr. Hagenschmidt was a good role model because he was not only a serious scientist, he was a committed person who spent many years of his life trying to navigate his way through the political scene. And he was also quite intolerant of what he regarded as anti-scientific attitudes on the part of the public. And he was able to get away with it, of course, because he was a scientist himself. And some of us have a harder time with that. But we do believe that our programs have to be, and continually try to make them as well as we can, be grounded in the best possible science. And we believe that the way to do that is by making use of research and, as much as we are able to, actually helping to participate in research ourselves. We are, therefore, a big consumer of what this meeting is calling actionable science from many, many different sources. Of course, we use health science to measure our progress, to attempt to understand whether what we're doing actually is benefiting the public health, which is supposed to be the legal foundation for what we do. We use it to try to identify areas where we need to be working harder. And so we sponsor and frequently collaborate in studies involving epidemiology as well as clinical studies and laboratory toxicity studies. We support engineering demonstration projects, and we actually fund demonstration projects for new technologies in the area of pollution control and more recently of energy efficiency as well. Although the State Energy Commission, through its peer program, is a far more important funder of research in the energy area, we have been able to collaborate with them effectively and to help them focus their research funds more on areas that are directly relevant to pollution control. And that's been a very, very productive collaboration. We also have been actively involved in advancing atmospheric science, both in the laboratories and occasionally through field studies. And we're very excited about the opportunity to join with NOAA and NASA, the Navy, and a number of universities in order to conduct 2 months of ground, aircraft, and ship-based measurements that will be going on next summer to address a range of problems from ozone pollution to the linkages between air pollution and climate change, a really critical issue for us in California, where we need to make sure that we are targeting our efforts in ways that don't have disbenefits across either one of those lines. We also maintain a meteorology program that provides daily support to local agencies in forecasting pollution and managing air quality. And we operate a statewide monitoring program that measures a wide range of pollutants and is used as a backstop for local agencies and makes its data available to places around the world. But the biggest item, of course, on our agenda and the new thing is AB 32, which has presented us with some enormous challenges to develop a program that will have a real impact that will demonstrate that one state, albeit a large and economically important state, can make a difference, even though we know we're only 2% or so of the world's emissions, and that we can do it in a way that is good for our state, not just that isn't too burdensome, but that is actually positive, because without that, I don't think we're going to continue to enjoy the political support that we need for taking aggressive action in these areas. And clearly the legislature, when it passed AB 32 and made all the findings that are in that statute, believed that there would be benefits to California, not just from helping to slow the rate of global warming, which we know will have serious impacts on our natural resources, on our public health and environment, but also that by moving out early and capitalizing on programs that we have demonstrated for years, particularly in the area of energy efficiency, but also with other kinds of advanced technologies, that California and its businesses and its investors and its universities, its research institutions, and the public as a whole would actually benefit from this program. Obviously, this is going to take a major infusion of new science, and getting to the 2020 goal, and certainly getting beyond it, is also going to require quite a number of new policy tools. Among those are developing new ways to rapidly assess and track changes in the state of our air quality, especially looking at the sources and repositories for greenhouse gases, as well as looking at tools to deal with land use, which is always the big and very difficult to deal with elephant in the room whenever we talk about energy demand or transportation, and which we also know not only affects our demand for energy, but also has a feedback effect into local climate processes. We're also increasingly concerned about the state's agriculture and its natural vegetation, which have significant impacts on both air quality and climate processes. And although they are no longer the most important element of our state from a pure economic perspective, the role of agriculture in this state as a provider of food is one that people are beginning to increasingly appreciate as we see what changes in climate are doing in other parts of the world. We also need to be looking more closely and with more precision at the effects of air pollution and climate change on our water supplies, especially the snowpack, as well as other aspects of California's physical and social landscape. Tracking these and other changes as they are going on a real-time basis can provide us with a wide range of data that in turn can form the basis for our activities. And we do have access to many sources of data, just as anybody else in this position would, and we use it in terms of developing our rules and evaluating our progress. And we are recognizing increasingly that as our work takes us into areas that are beyond what we've done before, it's no longer enough to only look at whether something burns cleanly or not, or whether it does it within the state of California or not, but that we are suddenly involved in a whole new world of life cycle analysis for products ranging from automotive fuels to consumer products, and that we have to be in a position to be able to track emissions from cradle to grave to beyond the grave to reuse again, and to be able to actually make comparisons between various kinds of products in ways that we have never had to do before, and that, frankly, I don't think anybody else is doing either. So we are at the beginning, and we're at the cutting edge. Now, I'm not suggesting that all of this is visible from space. Obviously, the data that we deal with comes from a lot of different kinds of sources, including surveys and tests and engineering analyses. But I did want to at least give you some sense of the scope of our activities, and to make it clear that it would be great if some of the stuff that we do on the ground now didn't have to be dependent on the ground, where it's frequently subject to political and economic and other kinds of pressures, where our stream of data can be interrupted. I recently got involved in an issue involving one of our many monitoring stations. As I mentioned before, and I'm sure most of you know, we run this network of monitoring stations that are equipped with sometimes very delicate instruments that measure ozone, NOx, and other pollutions. They electronically transmit this data to a central laboratory where it's compiled and reviewed and then put up on websites. This data is really fundamental to our operations under the Clean Air Act, and the siting of those monitoring stations is critically important in terms of being able to determine whether you have a correct picture of what people are actually being exposed to. So the location, the height, et cetera, has been fought over, and the instrumentation has been continuously questioned, and the analytical techniques are always under review as well. We've recently become involved with a local agency in the San Joaquin Valley, local irrigation district, which has hosted one of our monitoring stations. We don't have quite as many stations in the San Joaquin Valley as we do in the South Coast Air Basin, because historically air pollution hasn't been considered as important a problem there, although what we're finding currently is that along with growth in that area also has come a major increase in ground level ozone and NOx problems. And I would say that in terms of local concern, probably air pollution is more of a front burner issue for folks in the San Joaquin Valley these days than it is for people in Los Angeles, where we've become a little bit blasé about these issues because we've been working on them for so long and because we've had a lot of success. Anyway, this local irrigation district decided and by a vote of their board, adopted a resolution that they were going to evict the air monitoring station that's on their property because they don't like it when the data are published in the paper and it's identified with them that there's bad pollution at this spot in the San Joaquin Valley, and they feel that somehow this is going to be turned against them and that they will become subject to regulation. Not clear exactly how, by virtue of having this station on their property. And it appears that legally they probably do have a right to just pick up this station and move it or toss it off their property if they want to. So needless to say, intensive conversations are going on because the network, the fabric of the whole monitoring program is subject to being completely torn apart if we don't have good data from this station on a continuing basis. These are the kinds of problems you get involved in with the ground level monitoring system, which possibly could be avoided if we were doing more of this stuff from somewhere else, like space. But in a larger, taking a larger view perhaps of this problem, our goal is to not just improve air quality at the sites where we monitor, it's to really to try to improve air quality across the whole landscape. And so we have to find ways to infer what the air quality is between sites and over the times that are not those that are on the selected hours or days. And we do this, of course, through some costly and time-consuming computer modeling. And this is another area where potentially being able to fill in the gaps on a continuing basis could be very helpful in enabling us to see the patterns of what's going on across a much larger landscape. Having overhead data available is also very helpful. Looking at the air quality over coastal oceans, where of course we don't have any continuous monitoring going on, as well as in wilderness and other inaccessible areas. And as we've been so graphically reminded in the last couple of weeks with the local fires here in the San Gabriel Mountains, there are some sources that are very difficult to plan for in advance and to have the monitoring equipment right where you want it at the time that you want it. And in addition to wildfires, that includes things like dust storms and toxic spills. And again, the ability to measure the impacts of these things on a broader landscape scale is also very valuable. There's also, I think, issues about utilizing the overhead potential of collecting emissions data in the area of enforcement. This has been talked about for years. We currently have equipment in any major industrial emissions source that measures what's coming out, but many people feel that there are other ways that could be useful to take a look at the impact of some of those pollution sources. And then, of course, there are the intermittent sources or collective sources like cars and railroads and ships and so forth that we only measure occasionally in an instrumented way to really have a detailed picture of what any individual emission source is doing. So advanced and high-resolution sensors that allow us to see changing emissions through the day, compare weekends and weekdays, and track other temporal and spatial patterns that would allow us to improve our air quality models would also have a very positive effect on our ability to plan more precise and directed regulatory programs as well, and to target our efforts in a more cost-effective way. We don't really expect that we're going to be using satellites to do the smog check program to catch in-use violators. I think there's some things that probably will always have to be done on an individual vehicle-by-vehicle basis. But I don't think it's out of the question to think that looking at traffic patterns and the emissions that come from changing traffic patterns could help us learn a lot that would help transportation planners figure out better ways to design roadways, and alternative transportation sources to actually minimize their impact on the environment. And we have dipped our toes into this a little bit with some limited research projects using existing satellite data. For example, there's a project that's been looking at NOx that's being done by Professor Ron Cohen at UC Berkeley. But it seems to me that we need a much broader chain of people, from instrument designers and spacecraft managers and the agencies, us down on the ground, using the data to coordinate our efforts better. And again, that kind of coordination can come from meetings like this. I'm also very hopeful about what we will be able to do in implementing the California Global Warming Solutions Act to take advantage of new technologies. Clearly, this program has enormous data needs, and much of what influences climate is not so easily quantifiable, even as our traditional air pollution sources are. While the program itself is primarily focused on reducing carbon dioxide emissions from burning fossil fuels, in order to do really appropriate bookkeeping, we have to look at a number of other factors that influence climate as well. We're certainly looking at measures that will enhance carbon uptake from the atmosphere. The Air Resources Board adopted, I believe, the first ever protocol for actually measuring the impact of forestry practices that allow for management of a forest and cutting of trees, but at the same time do provide a method for giving credit for people who maximize the growth and life of older trees in their forests. And although this is far from perfect, it represents a real commitment on our part to trying to encourage voluntary use of better forestry practices as a way to help manage our contribution to global warming, as well as to improve our standing forests in our state, which are also under increasing threat. In addition to carbon dioxide, of course, methane is a very potent greenhouse gas, and except for some leaks that occur during the production of natural gas and in the transport of natural gas, it comes from biological processes, the way we manage things like sewage treatment plants, the amount of waste that's lying around on agricultural land and in landfills, wetlands, and so forth, and the ability to map where that methane is in better detail and to look at where the most promising opportunities are for coming up with ways to capture it and reuse it is a really practical but also very important and considerably underutilized technique, I think, in the effort to develop a plan to deal with greenhouse gases. We also need to look at land use changes that directly modify local climate. We know, for example, that irrigated crops are not the same as dry land farms, and that they in turn are different from natural or open space vegetation. Converting open space to urban or suburban use changes the local climate over and above whatever happens as a result of human activity, most notably through the heat island effect. And quantifying various aspects of urban and agricultural environments and enabling us to monitor these changes in the natural landscape is an area that has not really been looked at in our climate planning programs yet at all. And it's wide open at this point. We know that changing a surface from dark to white can cool the local environment. And we've been very interested in the results of a project in Almeria, Spain, where an area of 26 square kilometers was converted from open vegetation to nearly continuous cover of white-roofed greenhouses. And climate scientists are looking at this as a way to potentially significantly cool the land. But do we really want to be covering over all of our areas of open space in order to provide for cooling? Secretary Chu, the U.S. Department of Energy, suggested that change to reflective roofing materials could drive significant energy changes, and he's become Art Rosenfeld's latest convert to the idea of cool roofs as a solution to our urban heat island problems. But to take that observation that white roofs can provide a cooler area in a city and actually convert that to something real and measurable is not an easy task. And although not all of that should fall on the scientific community, we need an opportunity to take some additional looks at what's going on out there. And here's another place where I think a view from above could be very helpful. I'm sure there are many more examples and ideas than the ones that I've given you, but my job isn't to set your whole agenda, but only, I hope, to give you at least a few thoughts about why what it is that you're doing here today is important to us and relevant and urgent, and to encourage you to help us identify not only what the opportunities are, but also, as you see it, what the barriers are to our collaborating more effectively. Certainly we know from the governance side that it's difficult to train people, to get people to have the time to go and get training to use new kinds of equipment, to understand what some of these opportunities are. We know that institutional inertia, not to mention budgets, are real issues for all of us. But we also have plenty of examples, past and recent, where these barriers have been overcome. And certainly meetings like the one today are one step in helping to overcome them. So we want to thank you for what you're doing to help bring us more actionable science, and I look forward to hearing back from you when you've got more of it. Thank you very much.